You might be wondering, how did he get himself in this situation? More often than not, the answer is, it's fun. You may be familiar with Mark Rober, but if you aren't, go check out his YouTube channel right now. I've linked his recent video on Devil's Toothpaste below. It'll provide a lot of context about this project. When Mark Rober asked Science Bob and I for some help scaling up Science Bob's Erlenmeyer Flask Elephant's Toothpaste experiment, I was all in. And then he told us the reason, and I was even more in. We worked with Mark and set up some design requirements, and then we got to building. After extensive collaboration with Mark, this was our first test. Pretty spectacular compared to the ones that we had seen before, which were just tabletop versions. Our version 2 flask was definitely built stronger. Or maybe not. As with all of these experiments, they look super cool in slow-mo though. A little bit of a close call for my camera here, but it captured some really important data. The close-up here shows just how much pressure these things create. The additional strengthening we added clearly was not enough, so it was back to the drawing board to figure out how to make the next one work how we wanted it to. Next, we tried an experiment with a wider neck, which resulted in a very laminar flow and looked really cool, but it didn't really get the height that we were looking for. We could see in the slow-mo that this was exactly the type of effect we wanted. We wanted this to be as laminar as possible and go as high as possible. But you can see this didn't go very high at all. I will say though, the aftermath of this one was one of the coolest fluid foam dynamic situations I've ever seen. It was very cool. When the wind blew by, it made the whole thing move back and forth like a weird melting Jabba the Hutt lava flow thing. It was really cool. But we can't get distracted. Progress must be made. So for the next experiment, we narrowed the neck using the exact same thing, and we got a lot of height, and it was almost perfectly laminar. There was a little bit of feathering on the edges, but this was almost exactly what we wanted. This one was the most spectacular test we had done so far. We calculated we reached somewhere around 45 feet in this test. You can see it even got on the roof. Have a quick fun little POV shot here of the nozzle. You can see that it's very smooth and it looks really awesome. So after many more hours of testing and analyzing and 3D modeling, Mark, Bob, and I decided that we were ready to scale this up. So the next one we built was 10 feet tall. Due to an unfortunate SD card accident, I don't have all the footage of building the 10-foot flask. So enjoy what I have. So the morning that we were doing the 10-foot test, we had some issues with transportation, and we ended up having to hire a tow truck to come bring this to our test site. So we get it all set up. You can see it's pretty windy, and we were actually a little bit worried about that the day of, but it ended up working out pretty well, as you'll see. After sealing up the holes in the bottom and filling up the catalyst tank, we put on the front with only a few hiccups. We then realized that we were missing the ratchet straps that we had specifically brought to prevent the flask from bulging and splitting. But we thought we built it just fine, so it'll be okay, right? Let's watch that with a little more context. I'm standing next to the flask. The flask is 10 feet tall, and those walls are about 27 feet tall, just so you get a sense as to how high this is. We have a wire attached to a latch that is holding that bucket on a hinge, so when I pull that wire, the bucket dumps in. As I'm running away as fast as I possibly can, all I hear is a crack and turn around, and the foam is probably 3 feet from me. It was exhilarating, terrifying, and so cool. I'll tell you right now, it was hard to appreciate until after the fact when I saw the footage and heard the sound that it made. So I need to remind you guys, that noise you keep hearing when this explodes is the sound of 2x4s snapping in half. That is a lot of force. I was lucky. The way we built it and my safety gear would have protected me had anything come off of it when it blew up, but it was still very, very powerful, and there was a lot of pressure there. Enjoy this again from one more angle and some gratuitous slow-mo. And last but not least, my favorite shot showing just how close I got. I hope you've all enjoyed these videos of me almost getting obliterated by very high temperature and mildly dangerous foam. But I promise, we did everything in a very safe manner. These are dangerous chemicals, and we were always very careful around them. Although this was technically a partial failure, we felt that we had collected enough data and design information in order to build the next one. So the next step was to fly to California and build a 20-foot version. Thanks so much for watching, everyone. Stay weird, stay awesome, and keep making.